Hi, this is Alex from devstories.eu. PySpark Fundamentals, episode 18 of 21. You have a local data script that works perfectly, but suddenly your dataset size quadruples and your machine runs out of memory. You know the syntax flawlessly, but rewriting everything for a distributed framework takes days. The Pandas API on Spark bridges this exact gap. The Pandas API on Spark allows you to run standard Pandas workloads on a distributed cluster. It does not just blindly emulate Pandas, it intercepts your Pandas code and translates it into optimized Spark execution plans under the hood. To use it, you import the module named pyspark.pandas. The standard convention is to assign it the alias ps, directly mirroring the familiar pd alias used in local data science workloads. If you already have a standard local Pandas data frame in memory, transitioning is straightforward. You invoke a function called fromPandas on your PS module and pass in your local data frame. This converts the single node object into a distributed Pandas on Spark data frame. From that point on, the syntax you use to interact with this new object remains identical to what you already know. This consistency extends to how the data is processed internally. The distributed API natively handles missing data exactly as local Pandas does. If your dataset contains NumPy not a number values, the Pandas API on Spark manages them properly during mathematical operations or structural transformations. You do not need to invent new data cleaning logic for your Spark jobs. Standard operations translate directly. If you want to group your data by a specific column, you call the standard grouping function. If you want to compute the mean or sum, you chain the aggregate function right after. You can even call plotting functions directly on the distributed data frame. Spark processes the heavy computations across the cluster, aggregates the necessary data points, and returns the visualization just as if you were working on a single machine. Here is the key insight. The architecture underneath is fundamentally different, and that introduces a critical edge case regarding index generation. Local Pandas relies heavily on a sequential, strictly ordered index for every single row. Spark, however, partitions data and distributes it across multiple independent machines. Enforcing a strict, globally ordered sequential index across a distributed system requires constant communication between worker nodes. When you create a Pandas on Spark data frame without explicitly defining an index column, the API automatically generates a default index to perfectly mimic standard Pandas behavior. Creating and maintaining this default index requires synchronizing state across the entire cluster. If you are operating on a massive dataset, this synchronization introduces severe performance overhead. The API will often issue a warning regarding this internal overhead when it executes. To avoid this bottleneck, it is highly recommended to assign an existing column as the index right away, or configure the API to use a distributed friendly index type. The Pandas API on Spark gives you the exact syntax of Pandas, powered by the distributed execution engine of Spark. But remembering that strict sequential indexes carry a heavy synchronization cost will save your cluster from unnecessary slowdowns. That's it for today. Thanks for listening. Go build something cool.